Making multiple blinking lights. We're in the TinkerCAD circuits playground, I guess I'll call it. And what we're going to do is we need to bring in Arduino Uno. So I'm going to bring in the Arduino Uno. I'm actually put it towards the bottom of the screen. And we want to bring in a small breadboard. Okay. And we want to make multiple blinking lights. And we want them to blink at different rates. So we're going to need a little bit some coding actually in the back of this. So one of the things I want to do is, I guess we got to bring in all our lights. So there we go. Here are the LED lights. I'm going to put them in here. And we have our anode and our cathode. Oops, that's not where I wanted it. There we go. 1. I'm going to make 4 actually. 2, 3, 4. I'm going to change their colors just so we can maybe refer to them differently. Blue, red, orange, and we'll make this one green here. Okay, so we have our lights, and what we need to do now is we need to bring in power. One of the major parts is we got to make sure we have a grounding wire. Okay, so we're actually going to draw a wire from the ground to the negative here, and we'll make that black just to kind of represent grounding. Okay, we also are going to have to make sure that from the cathode, okay, so from the cathode, we need a wire to go from that same row to the ground. We need that for every single one of these lights to make sure each of the lights is also grounded. And I'll explain why I put the lights on the other side of the breadboard in a moment. The next thing I want to do is because I'm going to program each of these pins differently. We're going to have 4 different pins. The electricity is going to travel from pin 13 into this row, and then I'm going to use a resistor just so we don't run out the life of the LED. Okay, otherwise the resistor will be too large. Oops, sorry, there'll be too much electricity going through it, and it'll eventually burn the LED out earlier. So I'm going to put a resistor in every single one of those rows. I'm going to set it to 220 ohms. In fact, the program will even tell you when you have too much power going to the LED. You can even try it. You know what we'll do? We'll leave the last one so you can get used to that. I'll leave that one the same, so you'll see a warning will pop up as we go through it. So what I've done is pin 13 is going to control the red light. Pin 11 is going to control the blue light. Pin 9 will control this yellow orange light, and pin 7 will control this green light. And the reason I'm going every other one, because in real life it can be sometimes difficult to put our wires into these pins when they're next to each other, so I've spread it out just a little. Now I've done that. I actually need to make code to get these all to start. So let's say we were to start a simulation. What would happen? Initialize this, and you'll notice just the red light's turning on. It's actually already input some basic code, but it's not really our goal. We need a little more than that. So let's take a look at what the basic code was. What they did is set the built-in LED. Well, they put all the LEDs to that, but that's not exactly what we want. What we need is, I'm going to get rid of some of this code, is we need to set a specific pin. So I'm going to set pin, and the first LED we're going to work with is the red one, so pin 13. I'm going to set pin 13 to high. Then I'm going to wait just a second, okay? And then I'm going to duplicate this to set pin 13 again, but this time to low. So you'll notice that when we start the simulation, we're going to start to get a flashing light. Red light turns on, and it turns off, turns on. Oh good, it's turning on and off. It's set to loop, which is great. So the next thing I'm going to do is I'm going to stop that, is we're going to set up the second LED light. What's neat is I don't have to drag in all of these blocks. I can just duplicate these 4 blocks and attach it below. And instead of pin 13, that was the first pin, the next one we had was pin 11. Okay, so I'm going to do pin 11. Oops, sorry. That was not the right spot. We need pin 13 to set high, then low. Then we need pin 11 to set the high, and then pin 11 to low, except that I want a different interval. I want this one to stay on for 2 seconds. I still want the waiting to only be a second. I don't need it to go to 2 seconds. You could change it to that so you're waiting longer between them, but that's not what I want. for this one. So let's click away from that wire so we can see more. And we're going to start the simulation with the code. So now for a second it goes in, lights up the red light, and then lights up the blue light for 2 seconds, and repeats. Okay, great. Now we just have to do it for the last 2. So again, I can just duplicate all of these blocks, and I just got to make sure that I change the numbers correctly. So as I scroll down here a little, remember the next pin I set was 9. So after pin 11, I'm going to go down to this one needs to be pin 9 and pin 9. And the very last pin we controlled was pin 7. So pin 7 and pin 7. And we did want the times to be different. So when you go pin 9, hey, let's do this one at 3 seconds. Still only wait 1 second. There's no reason to have them all off for a longer period of time. And 4 seconds. Okay. So we've set up all of our code. We've done the pinout. Let's start the simulation. So the red light should go on for 1 second, turns off for a second. Blue light 1, 2, turns off for 1. 1, 2, 3 for the orange, off for 1, and 1, 2, 3, 4 for the green, off for 1, and then loops. It repeats. So it's continuously going through this. That's how these microcontrollers work. They continuously loops in terms of their code. So we've set up all the block-based coding here. And we have 4 different lights that are turning on at different intervals. They're going for longer or shorter periods than each other.